Masterclass, on est ravis de vous voir aussi nombreux. Alors, prochaine masterclass dont la thématique est la suivante, l'essor de l'Internet des objets et son impact sur la cybersécurité. Pour intervenir sur cette masterclass, Akima Chaouchi, elle est professeure et responsable en souveraineté numérique et sobriété à l'Institut Mines Telecom. On peut l'accueillir. Très bonne masterclass à tous.
Merci, bonjour. Bonjour à tous. Merci beaucoup d'être donc à cette masterclass que je vais donc faire en français et en anglais. Donc je présente l'Institut Mines Telecom très rapidement, qui est donc le premier groupe des écoles d'ingénieurs donc publics qui a un ancrage au niveau national, donc des écoles d'ingénieurs du numérique et de commerce. Et donc les enseignants-chercheurs dans nos écoles d'ingénieurs forment les donc compétences dans les différents sujets donc du digital et aussi en lien avec la société et l'environnement. Mais c'est aussi des chercheurs et des partenaires avec des projets industriels d'innovation. Et donc on a la dimension formation et puis on a la dimension compétences industrielles et on anime aussi un réseau d'incubateurs très actif qui généralement se nourrit de cet écosystème d'élèves ingénieurs, mais aussi des enseignants-chercheurs. Alors, quelques chiffres. Donc, on a 1200 enseignants-chercheurs sur les différents sujets qui nous occupent aujourd'hui, donc sur la souveraineté numérique, sobriété, mais aussi sur l'industrie, sur les sujets liés à l'impact environnement et au sujet SHS. Et donc, on a cette expérience-là, comme je disais tout à l'heure, d'innovation avec les industriels, donc en plus du développement de compétences. Et tout en bas, donc quelques chiffres par rapport au réseau d'incubateurs qui est très performant. Comme vous pouvez le voir, donc on a à peu près 70 startups créées par an et avec 80% de survie sur 5 ans. Alors, l'Institut Mines Telecom a renouvelé son contrat d'objectif avec son ministère de tutelle, donc le ministère de l'économie, de la finance, souveraineté numérique et industrielle. Et donc, dans cette phase 2023-2027, l'Institut Mines Telecom se positionne sur les 4 thématiques stratégiques donc, qui sont la souveraineté numérique et sobriété, donc, qui vont toucher les différents sujets liés aux infrastructures numériques, au sujet donc, du cloud, de l'IA, de la cybersécurité, de l'électronique, le quantique. Et puis l'accompagnement justement dans l'innovation avec le digital des entreprises. Un lien aussi qui est assez fort avec donc les acteurs donc, publics, politiques, comme par exemple France 2030, dont des objectifs en lien direct avec les orientations européennes pour la souveraineté numérique et sobriété. Et donc, au niveau de l'Institut Mines Telecom, j'ai la charge d'animer cette thématique stratégique. Et à mes côtés, donc, j'ai d'autres animateurs de la thématique stratégique ingénierie, santé et bien-être, et l'industrie du futur responsable, et puis l'énergie, l'économie circulaire et la société. Donc, on a bien cette dimension donc, action nationale pour nos acteurs industriels, lien fort avec les politiques publiques qui elles-mêmes sont en lien avec le niveau européen pour avoir une trajectoire harmonisée au niveau des sujets donc formation, innovation et bien sûr recherche. Alors, je suis ici grâce donc au programme de transfert cybersécurité au campus cyber à la Défense qui a organisé donc ces masterclass. Donc l'Institut Mines Telecom est partenaire du PTCC au campus cyber. Donc j'ai mes camarades qui sont présents ici. Ça fait plaisir de les voir à cette occasion. Donc le PTCC vous a été probablement présenté, mais j'aime bien le remettre ici avec ces 4 puzzles donc qui font justement ce travail au niveau national donc d'accompagnement du transfert donc de la recherche en cybersécurité vers un développement socio-économique. Et donc vous avez la dimension compétences, innovation, recherche et animation. Et donc aujourd'hui, je suis en charge de cette masterclass qui a été organisée dans le cadre du groupe de travail donc formation et compétences du PTCC. Et donc j'ai choisi pour vous le sujet donc de l'Internet des objets et l'impact vers la cybersécurité, et je vous donnerai aussi quelques pointeurs vers les différentes formations de l'Institut Mines Telecom sur ces sujets. Et à partir de maintenant, autorisez-moi donc de switcher en anglais. So, As everyone knows, internet is something that we have in hand today. From technical point of view, what I would like to stress as a first point to start this masterclass is that internet is a unique standard. So what you have on the phone, smartphone, on the computer, is using the same communication standard, right? And from business point of view, internet is a very strong economical vector because it had an impact on different industries. And as you can see here, it is a powerful technology because here you have an example of what happens, for example, in 1 minute inside the internet, and you could see different applications, either, you know, data transfer, video transfer, video calling, etc., etc. And internet is not collapsing. We even want to have more with internet. We want to have more than our smartphones and computers connected. We want to have objects connected. What is an object? I know that you already heard different presentations on the topic, but I wanted to go maybe further in the history, 18th century. Before talking about connecting objects to the internet, in fact, the first phase for the object was electrifying the object. So we moved from mechanical object to some object with electricity. Great. That changed, I think, the applications that we could use with those objects. Then in the 20s, we were thinking, okay, electronics is doing really great. We have miniature, electronic devices. So why not connecting objects to the internet? And we have a powerful internet. So in fact, there, with the ambition to have objects connected to the internet, there will be the question of, after the electricity, what would be the connectivity you will have to go to the internet? Of course, people who would like to do this, they are not interested just to connect objects. They are having real business problems. They want to make some automation in different processes. So then, for a telecom engineer, the first thing we do is to look, on the shelf if there are existing, electrified and connected objects. And in fact, there are plenty. There are plenty of sensors, and there are also plenty of what we name actuators, like you can remotely, actuate some processes. And here you have some examples: temperature, pollution, maybe the presence of people in a room for access control, etc., etc. So we have connected devices. Then, the block of connectivity. In fact, the block of connectivity is just flourishing for years now, and we have plenty of connectivity. You could have short-range connectivity, you could have long-range connectivity, you could have a free access connectivity for an object, you could have paid connectivity. So everything is on the shelf. But for security guy, when he looks at this, he's just scared. I mean, you will have different objects, heterogeneous, different connectivity, and we know that when it's not a unique standard, it means that for each connectivity technology, you need to have expertise on the vulnerabilities and attacks that you could have on these, connectivity technologies that we could use. Again, why do we connect these objects? Here you will have the experts working with data sets, artificial intelligence, who proved, and we know, that automation today is possible in different domains. So in fact, it is a story of digital transformation of industries. We want to have more and more automation, and to have more and more automation, we need to have more and more connected devices. So there, for someone who would like to develop an Internet of Things project, you first need really to think, is it going to optimize something? And is it going to be impacting some other things? For example, if I decide to put, I don't know, monitoring sensors for health, okay, so for medical monitoring is good, but the data that we are capturing, probably we need to think about the security impact of such automation processes. This is just an example. So you have, for researchers, we have surveys and different, things to synthesize, you can start from the terminology, but in fact, for Internet of Things, you have heterogeneity at different levels, even in the terminology. So here you have examples of terminology. So for example, if I speak about cyber-physical system, immediately I know that this is for some industrial domain related to manufacturing, automation, so there is some criticality in the communication. If I use, for example, the terminology machine-to-machine, I know that this is coming from internet engineers because we already have standards for machine-to-machine. And if I use the terminology machine-type communication, I know that I'm speaking about 5G connectivity. Okay? So if I design IoT projects, I need definitely to have different profiles in my project, and one of them is the telecom, engineering profile, because depending on the domain or the application where you want to put the Internet of Things, you need to know the performance of the technology, but also if there are specific attacks behind this technology, because as we said in the beginning, there is no unique standard for IoT. Okay. So I put this picture for you that is trying to put more sense of what I'm trying to picture out for you here. In fact, for this unique standard, when you take a device, internet device, when you look inside, you will find these electronic components you have there, the memory, the processor, the operating system, the communication protocols, the applications, and all these things, in fact, are standardized. There were several years, in fact, of standardization, and one of them started with the connectivity part. That's why the connectivity is a hard point also in the Internet of Things, right? Now, in the Internet of Things, we don't have unique standard, but we have multiple objects. So heterogeneity here becomes again a problem, because Internet as a unique standard was just hiding the heterogeneity of devices. Here again, in Internet of Things, we have heterogeneity as a problem. So if I have to build, I don't know, an IoT application with thousands of objects, if I don't take the objects from the same manufacturer, maybe I will have interoperability problems in my automation process. So here I give just some examples, and just to show that in Internet of Things, we didn't start with standardizing the protocols. We started thinking about the device itself, the device manufacturing. Why? Because depending on the application, you could have big objects like a car, but you can have also very small objects like a little sensor. And for a little sensor, you will have immediately a big problem, which is the energy, the battery. Again, go back to the object of the 18th, electricity. We have electricity, but in fact, at that time, for us, it is in the wall. But with Internet of Things, we want to have electricity in the object that could be anywhere. So this is, again, another problem. Now, I want to put also this picture for you, just to show that depending on the IoT applications, in fact, we use different technologies. And historically, there were some technologies very old, even during the Second World War, like, the identification technology. Identification technology became interesting for, Internet of Things around 2000, because logistic domain wanted to use some automation in the logistic management. Then here you have, for example, RFID for identification. And from cybersecurity point of view, in fact, the communication from the object which is connected with RFID to the first point that goes to Internet is having its specific security problems. And the Internet security-related problems comes from the first access point to the network where the data is, stored and processed. Then you can go here. The second IoT, industrial interest was about, monitoring, surveillance, and all these, sensors that we could capture different data. And here, in fact, the functionality from the technical point of view for a telecom engineer is about sensing. And for telecom engineer, sensing is something like you have a device that sends information. We call this uplink, like it goes up to some server to store the data. So for security guy, okay, uplink might have less vulnerabilities than the downlink that we could see later here in the remote control applications. And in between, the monitoring and the remote control, that is very useful, for example, in manufacturing, in automotive, for example, for connected cars, think about this as, you know, a command that comes from somewhere from the internet to some objects. And there you have more security problems. And for an expert in IoT, you need to make a clear analysis on what are the vulnerabilities for applications that are related, for example, for identification, because an RFID is very, I would say, nice object because it's there, it's silent, and it can send, you know, messages only when someone asks him a question. So there you have some security solutions. When you have IoT applications using sensors, so apart from the problem of performance, of having a big number of sensors, you have cybersecurity related to the acquisition of this data, and then the cybersecurity related to the processing of the data in the cloud. And then you have this remote control, and in between, I put also the application, which is also very good in business related to localization. So this is just to give a link between this technology readiness timeline and the market access. Now, so I go faster. Yes, so here, in fact, in Internet of Things, in addition to the security problems that we have in classical, I would say, Internet application, you will have other problems related to, for example, regulation around the data that you are processing, because you are connecting objects that are usually not connected, and now they are talking, and you don't know that they're talking about information that are related to you. So here you will have the attacks that can be related to the taking the control, stealing information, and of course disruptive, you know, of services. So here you have another dimension with Internet of Things, which is related to, is my application that I am developing using data, is it in fact compliant to some regulation in the country? And, you know, for example, in Europe, we have the data privacy, you know, regulation, which is very important. So even if you have a very good technological solution, if you didn't anticipate the regulation part, then you will have a problem to really deploy the solution. So with putting the connectivity so broad, getting more data, we are having additional security problems that are not related necessarily to the technology, but they are related to the regulation that we have on top of managing this data. Even though we have security problems, there are already applications. So here I give the examples: connected homes, connected buildings, connected, you know, smart cities, health with digital. And a successful, I would say, IoT project is the one, as I said before, which is taking all these considerations in the beginning of designing the project, and not just taking technological solutions and installing them to run. The application will run, but you need to make sure that you have, in addition to the performance, the security of the technologies that you are you know, choosing, and also that you are compliant to the regulation. So clearly, the IoT security challenges, if from technical point of view, in addition to the data privacy, I could add also the problem for, you know, a network administrator in a company, for example. You don't have a smooth solution to identify all your IoT objects and use them in the information system of the company. So the lack of visibility makes new backdoors open in an enterprise company that is adopting, for example, connected objects without a clear security layer designed specifically for the IoT projects. As I said before, depending on the application that we are using, we can have a proof of concept to show that our solution is running. But definitely, depending on the data that we are using, we need to check the regulation. And at Mines Telecom, in the digital sovereignty and sobriety, we have an interesting expertise with different working groups, for example, at the European level, trying to guide also the research that we do in compliance with digital sovereignty and sobriety. Here you have another example with the industrial IoT. Here we'll have another problem, which is the criticality of the communication. And usually when you add security to the communication, the real time of the connectivity will not be good. So here it's an optimization problem where you need to have real time, so fast connectivity, but at the same time you need to have security. So it's not easy solution to solve. We need to do research more on that. Then you have smart buildings. Here, the example of smart building is interesting because with IoT, you have, for example, physical access to objects. And a simple example is like if you use a certain connectivity in your object where authentication is weak, like I just need to take the object and then get the password which is inside, and all 1,000 objects are having the same password, then you don't have security in your IoT solution. So this is about like this outdoor exposure of objects. And then we have Internet of Things that are used in some industries that are critical. So we speak about vital operators. In French, we say opérateur à impact vital. So when you add an IoT network to some vital operator, there you have also a security level which is really high, in order to make sure that you are not opening back doors where you have an attack that can make a blackout of all the electric grid in your country. So you need also to measure the dimension of the impact of the IoT application and the automation that you are pushing on other consequences of the application. So coming back to the internet technology, okay, we said that we have all this heterogeneity in the devices, but at least we agreed, when I say we, the technical people agreed that the architecture for IoT is simplified in the phase where you push the data into the cloud. So we have this 3-layer architecture, and for me the message here is, in addition to focus on the security issues that we have on the connectivity itself of the objects, on the object itself, for example, if I have a weak authentication on the object, it is also important to look at the internet, layers. And in fact, here, as we are using the standard internet solutions, we have security level that is offered by internet protocols. So what we should take care of is the regulation part related to where you put the data. So if you are putting, for example, an IoT solution that is running some data coming from the health industry, then you need to make sure that your cloud provider, because you are not running the cloud, you take a provider, you need to make sure that it is compliant to the security that you have in the country. So in France, for example, you have Secnum Cloud from NC, which is labeling different cloud providers. And here I will go really fast. For the technical part, we have a lot of research projects and innovations in Mines Telecom and also in the national ecosystem to possibly advise also on the advances that are happening in cybersecurity in these technologies. And again, in the telecommunication part, you have different technologies, free of access, paid, licensed and licensed with radio. So technically, you can have really a good choice of these technologies. So I'll finish on this slide for the technical presentation, and I'll show you just a few links for the education part. So as I said before, for the security in Internet of Things, the problem, of course, classically is technical, but you need to make sure that you have the right team to cover all the knowledge about the regulation and all the other aspects. So even though we don't have a unique standard for Internet of Things, but we have best practices, and this is one of them, to make sure when you design the solution for your IoT project that you are following these best practices guidelines. I have 3 examples of research projects, but I'll skip them. One is about interoperability, ongoing in my research group in Mines Telecom. So we're having an abstract layer to manage the interoperability problem. And then I have 2 examples related to data anomaly detection that we can use either for the performance of process or for cybersecurity. And we have good collaborations also with some industrials. I'll skip that one. And then Je passe à la partie en français pour la formation. L'Institut Mines Telecom, donc, en plus des formations ingénieurs, il propose donc un catalogue de formation continue. Et nous avons une collaboration en cours aussi avec le PTCC pour des formations communes. Donc, par exemple, ici à Télécom Sud Paris, donc 2 formations, master spécialisé en cybersécurité et une certification aussi en sécurité pour les industriels. À Télécom Paris, donc on a dans Télécom Executive Education donc une certification d'architecte IoT que j'ai coordonnée, donc ça reprend un petit peu toutes les technologies. Donc vous avez le contact des personnes ici. Après, vous avez à l'IMT, donc Mines Saint-Étienne, aussi des formations donc, très spécifiques sur la partie hardware, mais aussi sur la partie technologique de cyber. Vous avez aussi des formations à Mines Alès, à l'IMT Nord-Europe, et vous avez aussi les contacts pour IMT Atlantique. Et j'ai mis une slide ici pour donc la liste complète donc, de formation au niveau de l'IMT. Vous avez les contacts, donc vous pouvez avoir accès aux slides. Et je termine en vous disant que je suis ici, donc dans ce village recherche. Si jamais vous voulez échanger sur vos besoins autour de projets IoT, aussi bien en formation, recherche et innovation, n'hésitez pas à passer me voir. Merci. Thank you.
Akima Chaouchi, merci beaucoup pour cette masterclass.